Now, for our next session, we're excited to have NVIDIA joining us. NVIDIA, of course, an industry pioneer, one of the biggest names in AI. And Laura Salitos is the principal cloud security architect at NVIDIA. And she'll be discussing with us security in the age of AI, delving into the urgent need of enterprise architecture to be transformed to accommodate AI-driven workloads. Laura will also be touching on the company's role in strengthening cybersecurity, including NVIDIA Morpheus, digital fingerprinting, and behavior analytics. So, without further ado, take it away, Laura.
All right, thank you everybody for attending today. My name is Laura Salitos. I am a principal security architect at NVIDIA. Today I want to dig into security in the age of AI, specifically digging into the security perspective of this rapidly changing AI landscape. We are seeing an explosion of data happening every single day in our data centers across global traffic. We are seeing more connected things, more connected users, and just overall more data being generated. As a consequence of this, when we start seeing breaches, we are seeing an average total cost going up. We are starting to see the average day to contain these breaches exponentially increasing, as well as a massive uptick in victims of these attacks. I'm not sure about people on this call, but for myself, for others, we are starting to see more and more direct impacts of these breaches, whether it's your own personal PII information, or if it is part of a corporate breach that you're involved with. The overall landscape is changing every single day. 2 years ago, we had a major moment in history where things changed. This started a new era that we have honestly never seen before. Jensen mentioned that this is the AI moment, or the iPhone moment for AI. This is a major thing that happened specifically around the introduction of ChatGPT. The reason it was such a massive splash in the industry is because it only took 2 months to reach over 100 million global users. This is something we've never seen before. This is not just a new moment in the landscape, it is a new moment for users, for individuals. We are starting to need to ask the question of why did this become so successful? Why were people able to join something so quickly? This is where when we dig into the success of ChatGPT, we get the answer of accessibility. Back in the day, you needed to leverage CLI or command line interface to be able to grab this information. You needed to have some sort of expertise in programming, even if it was basic coding abilities. But now we've introduced human language interface. This is where I can just talk plain English to a chatbot and get results back. This is where I can start interrogating it to get my data. I can ask it to help me solve this problem. Can you connect these two different data sources and generate a chart for me? This is where we are starting to see a very different era emerge. And with every new era, we start to deal with new types of risks. Because AI, at the end of the day, really means that everybody is now a programmer. If we rewind about 15 years ago, there was this very small technology called cloud computing that many said would never take off. In this scenario of cloud computing, we put the developer in control of the end-to-end stack. This was a massive paradigm shift for us that we were not used to. And what we're now doing with artificial intelligence and what we're now seeing with ChatGPT and other types of LLMs is that everybody from my parents who are not in IT to our HR personnel, to our marketing personnel, sales, to our most advanced engineers, now everybody is a programmer in this ecosystem. And everybody is now interacting with data in ways that we have never encountered before. So when I look at this problem, it really breaks down to where is cybersecurity in this new landscape? The way I talk about it is in two different areas: security of AI and AI for security. A lot of people on this call will see the similarities to cloud computing, right? This is what we would say in terms of security of the cloud or security in the cloud. This is really just an advancement on that theme. Cybersecurity, at the end of the day, is a data problem. The data is there. Can we find it? Can I find the adversary in high velocity data streams? Can I find it in heterogeneous data sets across my entire organization? Can I find it in real time? Can I find it near real time? Can I find it as close to the point of exploitation as possible? Can I do it while I'm dealing with a staff shortage, where I don't have as many people or analysts able to dig into these queries or these problems? Can I do it while my limited staffing resources are hit over and over by an exponential increase in alerts? They are navigating and dealing with alert fatigue. All four of these problems just exponentially increases on us, and we have to defend our enterprise to enable this new era of artificial intelligence while still enabling our business to achieve innovation. Market opportunity that we're seeing is over a 6 times increase from 2022 to 2023, and this is still growing. I don't have the numbers yet for 2024, but we are seeing a massive uptick. What this means is that we're starting to see over 70% of cybersecurity operations that are starting to incorporate generative AI technologies. Even simple solutions like summarization and analysis will end up saving hours, if not days, a year. This really enables our teams to start going after more advanced threats. This is that explosion we were talking about with the ChatGPT graph, where we saw over 100 million global users in 2 months. This is that explosion that we're starting to see. And we're starting to see it in our work environments every day. And as a result of that adoption from our cybersecurity professionals and in our industry, we're starting to learn more and more. We've learned the hard lesson that we can't just throw ML at the problem. If we're trying to throw ML at anomaly detection, we've seen that everything starts looking like an anomaly. Starts adding more noise for our analysts to dig through. We are all using computers different every single day, so there is no standard pattern that we're able to replicate and investigate into. There are some, don't get me wrong, and of those repeatable patterns, those are easy for us to encode into our threat detection tools. But overall, the more difficult problems, these more advanced anomaly detections, it's a very, very difficult problem to solve. And it is honestly creating a lot of noise for our analysts. But that doesn't mean that there isn't hope. When I dig into this problem, I try to break it up into 3 categories, looking at it from the point of view of an attacker, a defender, and a user. Every attacker tool I try to imagine is just a precursor to a really cool defensive tool that we get to use in the future. The difference, an attacker only has to be successful one time, whereas the defender needs to be right every single time. So we obviously have more challenges on the defender side, but we can use this as an opportunity to advance our skills and learn from each other. It comes down to a problem and a challenge of timescale horizon and effectiveness. So I'm sure everybody on this call is familiar with the age-old scam of the Nigerian prince who has large sums of money that they just want to share with you. They just need help transferring it around and you will get a cut. This is a issue of quality, of scale, time horizon, effectiveness, right? If we take this scam example and leverage generative AI to improve it, we're able to customize the spam attack. We're able to make it more personalized, customizable, more of a quality attack. On the flip side, we can also use generative AI to detect some of those. So again, we're able to use this tool on both sides of the fence. Wanting to dig a little bit more into what does it look like for the new age attacker, we are starting to see more and more low to no code tools being leveraged. There is a much lower barrier to enter into this type of attack surface. What this means is that what used to be an average attacker can now achieve expert level attacks. This is making it not only more difficult from a defensive side, but it is also decreasing the amount of time that these attacks can happen. We're starting to see higher scale as an output from these attackers, but also a decrease in time from when they're starting to reach this level of sophistication. Transitioning over to what this means for our end users. Let's put ourselves in the user's shoes. When I'm talking about our users, I'm talking about our spouses, our friends, our parents, grandparents, really people that are not technologists. The advice I have always given to family, to friends, is don't click on links. Please don't download attachments, right? This is the commonality we've had for our users for decades. That is starting to change now. An example of how it's changing is an example our Red team has dug into here, where this is an example of a plugin that was added to one of our chat GPTs that is resulting in exfiltration of sensitive data. The attacker in this scenario would have put malicious instructions on a website, essentially resulting in an indirect prompt injection attack. The browser plugin that they have added accesses that website. ChatGPT will start following the website's instruction. In this example, maybe retrieving the user's email, summarizes it, encodes it into the URL, appends that into the attacker-controlled URL, asks ChatGPT to go retrieve it, and now the attacker has your personal information. This is a very high-level, easy example of where the user did not click on any links, they did not download anything malicious. It's turning into a world where we need to start educating end users to even just not ask bad questions. Don't ask the wrong questions of your Copilot, because it could result in you having an exploitation by accident. So we're really having a paradigm shift of education with our end users, where we're having to have more suspicion and not trust your Copilots necessarily, or the data based on the questions we're asking. Now, looking at the New Age Defender, I want to break this down into two parts. What's been done in the past and being done a little bit today, and where do we need to get to? So I'm sure everybody on this call is familiar with data-driven dashboards in a SOC environment, right? We work with leading vendor tools to have our centralized repository of data. We create dashboards to try and identify and monitor trends over time of those different data sources so that we can start acting on it. This starts coming into a scale and time horizon problem of tomorrow there's a new threat actor that we didn't have visibility into, so we're always doing this catch-up game. This is that data-driven SOC of yesterday. What we need to get to is more of a context-driven SOC. This is where we can interrogate and leverage human language interfaces to be able to get to the question or the context that we're looking for. This is honestly, like in the earlier slide, we talked about the explosion of adoption for ChatGPT. This is how they were able to get to the 1 million users in 2 months, by leveraging human language. I can just ask this type of interface to summarize the details of the user activity session based on authentication logs for this user, throw that in a chart for me, help me do that analysis very quickly on the spot. The New Age Defender is no longer just a programmer, they are a prompt engineer. This is where they are advanced and be able to ask explicit questions and interrogate the system with data. And then if they're able to get to something consistent, then we chart it. Then we put it on our interactive dashboards to monitor. But I really want to take that one step further. Patching systems. Patching is not easy. And honestly, I don't know about you, but I've seen teams spend more time justifying not needing to do the patch versus actually implementing the patch. We have a policy of no critical high CVEs. This, as you can imagine, results in some frustrations, some slowdowns, and some blocked launches. This is actually where we had an opportunity for growth internally, where our Morpheus team jumped in to try and reach speed of light to remove some of those slowdowns, some of those block launches, by the introduction of a agent that introduced self-testing for automated validation of these CVEs that were discovered. The reason that the Morpheus team was able to do this is learning from how we did standard container vulnerability reporting and analysis. So what is this container vulnerable to? What is the vulnerability exploitable? Is the vulnerability exploitable under these contexts? So in the past, where we ask these questions as an analyst and we dig into it, and 200 different Google searches later across the board, we can get to a yes or no answer and then potentially a release. Agent Morpheus is allowing the automation of that analysis through artificial intelligence. It's allowing us to use generative AI, RAG, powered by NIMS and other technologies to do that initial analysis. So now when we report on these CVEs, it's a much smaller, more targeted, more contextually aware list that our teams can then start working off of. Really, the goal that the Agent Morpheus Blueprint is trying to tackle is how can we leverage AI, but also use it iteratively to increase the speed for releases of our products while not compromising the security of them. The question is, how can I then apply these learnings in a more practical method? The answer is that whether you are a cyber professional, a technologist, a CISO, you need to start using AI today. You need to start pushing on these boundaries, continuously improving. If you don't, then you're already going to be behind. The amount that we have learned just because we didn't wait for things to be perfect, we just started doing iterative development and innovation. We have learned from that as we've gone through that process, and we've been able to create more innovative paradigm shifts. So when we start talking about pushing those boundaries, here's an example that we've seen over time. So if we go back to the 90s, this is, we joke about the golden era of security, right? This is where we get into perimeter-based security. You just put up a firewall and you're good, right? This was challenged, boundaries were pushed. We get into the 2000s, and this is when cloud was born. This is where we changed our model from into application-centric security. Zero Trust was born. But then as we started shifting everything into the cloud, we realized there was a large cost to it. So this is where the next iteration, 2010 timeframe, we see the introduction of microservices architecture. This is where we start breaking up those very large, expensive applications into these little micro apps with the goal of saving costs, pushing for reusability. And then this changed our security model to more of a data-centric security model. This is where we start seeing the emergence of attribute-based access control. Now let's fast forward to today. This is where we start seeing and introducing the idea of context-centric security. Let me give you an example of this. When Jensen went on stage for GTC last year, as well as this year, to give a keynote on product announcements, the product team usually has material created in advance. And of that material, some of that material can be released before Jensen's talk, and some of it needs to be released after Jensen's talk. This is where we start getting into a data classification problem, right? In terms of based on different kinds of contexts, that permission level changes at runtime or at data access. So now I have to literally classify every word and every phrase in a document. It's the easy answer for that. I'm sure many professionals are starting to see this default answer where we'll just say system high, high classification for all of it. So we have all the data in our organization is now top secret. That's not scalable. That doesn't work. That does not enable the business to be successful and to innovate. So we have to go back to the drawing board to understand how can we solve this data classification, this context-centric security challenge at scale for organization. And to be fully transparent, we have not solved this. We have made progress, and I want to share that with you today, but this is something that we have to continue to iterate on top of. So this is a very similar chart to what we were just looking at. This is starting to get more into procedural-based access to systematic. I can lock down my SharePoint and everything else, but how do I now do that as I get into runtime and access? And this problem, honestly, starts getting harder and harder in the new era of security that we're finding ourselves in. I want to start giving more real-world examples to what I'm talking about to give some context. So in an organization, we have Google Drive, SharePoint, we have several different types of repository with data classification and access layered on top of it. But what happens if you do not have it 100% locked down? You can just slap guardrails on it, right? I can put a little bit of tape over my fundamental problem. Unfortunately, we don't see that working. There are benefits to guardrails, but it does not solve the problem. It is one of the layers of security in depth that we want to look at, but here's an example of how we got around it. This is an example that our red team did internally to get around some of those to be able to simulate a indirect prompt injection attack. In this example here, the red team created a new NVIDIA Leave policy based on the Death Star. We then shared it with the entire company, specifically to disabling notify users. So this passively was shared out, and it meant that it was picked up by our internal HR expert bots. So what does that mean? It means that the impact of this is that when users interrogated these HR expert agents to ask about our company's current leave policy and time off, they were given very Death Star related responses that had nothing to do with our actual policy. So a fun example that we were playing around with, but it shows the potential impact in a real world scenario. So this shows us that the context of use matters, as well as where the data is coming from matters. So now every single line of every single document in my enterprise requires access control. The traditional model that we're familiar with is the data-centric security. Data repository access controls across this that we're seeing on this slide. Now the problem is when we break this down to how do I do this based on derivative classifications and derivative documents that come out of my enterprise? And this is where the whole concept of context-based access control comes into play. So if we had taken that original, that traditional data access control stack and threw chatbots or copilots on it, we ran into a big problem. It was so much data, and honestly, we were just getting garbage coming out of it. And we struggled to answer the questions of how do we make this relevant? How do we access control it? How do we improve the data coming out of it? The answer we got to about a year ago, we decided to start deploying internal bots. We called this concept expert agents. So we had expert agents for marketing material, financial data, HR and payroll, and sales. This allowed us to do system high level access provisioning, but at the individual expert bot levels. It's a little bit of a hack, but it allowed us to start solving a bit of the problem because we don't have a solution to context-based security yet. This actually helped make our bots more valuable to us though, because it made them more specific, more intelligent, more accurate. And in addition, it had the benefit of solving some of our security challenges. Now, the question once we have these expert agents is how do I then look across all of them? How do I allow my user to ask questions of them? This is where we have access control at the agent level on top of that for agentic workflows, which is, again, very difficult to start doing security around, but the way we've approached it is really for security controls. We've obviously broken down the enterprise into these experts. We've done guardrails at those agent levels. Then we have limitations based on what you can access for each of those agents. And then layered on top is final guardrailing. So I want to take a step back and understand what, as security professionals, can we do today? We need to stop saying no. We need to understand how we can start phrasing it as, this is how we get to yes. That's how we as an industry, as professionals, are able to learn as we iterate and innovate into these domains. If we waited till everything was perfect, we would not have had these lessons learned. We've had to have different kinds of internal bots at NVIDIA blocked. We've had hard conversations that if we hadn't started doing over a year ago, we would not have the solutions we have in place today. So this is where we're really trying to push boundaries. We're iterating as much at the speed of light as possible. And we're learning a lot in terms of how does this map to what we already know. AI solutions we're starting to see are just iterations on cloud computing. They're just a new app. Our goal is to make sure that we're upgrading and evolving our SDLC practices to make sure that they're inclusive of generative AI systems. You can't skip it. And we've found that AI is not just going to solve this problem for us. It'll enhance us, it'll help us, but is not going to just completely solve it. Really, the approach comes down to you need to figure out what your organization's approach to content is. Where is all your data coming from? Is it clean? Can we leverage the concept of software bill of materials, SBOMs, in the future? This is something that us as NVIDIA as an organization is putting a lot of emphasis on. We want full transparency from ourselves that we're giving to customers as well as the vendors we're working with. We want SBOMs, we want model cards, data cards. We want to have that full transparency of data so that we can understand, start labeling, start having that kind of access control around it. There's a lot of unknown ahead of us as this explosion of AI is happening. There's a lot to learn, both from our adversaries as well as our defenders, as well as our partners in the industry. That's why I'm a huge proponent of transparency, of sharing information, as well as sharing information about models that we're building through model cards. And as I've said earlier, if you wait until everything is perfect before you start leveraging AI, you're going to be so far behind. So we need to be able to embrace the change of it, work to be able to support these breakthroughs, share this information with the industry to help each other out. Thank you very much for your time. I appreciate this collaboration, and I'm excited to learn from the other talks today. Thank you.